Hi guys, so in this video we're going to be going over some trigonometric identities that you will be getting in the exam. And you may be wondering, why am I making an entire video based on this when you're already going to get it in the exam and it's already there sitting there waiting for you? Well, firstly, because I wanted to show you guys how it came about, so it can just make a bit more sense as to why something is the way it is. And the other reason was because I also think that going through the process of proving stuff will help you when it comes to proofs in either IB math or even in GCSE math. You will be asked to prove a lot of trig identities. And it's important that you're able to whip these out when necessary and know what's appropriate for which scenario. So I'm going to start systematically. So I'm going to go first with the tan x equals sine x over cos x. This is the first identity I will be proving. So as we know, tan x is equal to the opposite over the adjacent. So I'm actually going to station a right angle triangle right over here. This will be a constant reference point. So let's name this the angle theta. So this is the adjacent, this is the opposite, and this is the hypotenuse. So tangent is opposite over adjacent. We also know that sine x is equal to the opposite over the hypotenuse, and cosine of x is equal to the adjacent over the hypotenuse. So I'm going to show that doing sine x over cos x should give you tan x. So sine x is O over h, and we divide this by a over h, which is cos x, which gives us O over h times h over a, if we use division, which gives us opposite over adjacent. So I did mention this before in the unit circle video, how we can use this to therefore calculate tan x by only knowing what sine x and cos x for different angles, but I just wanted to reinforce this identity. Now, this identity is the one that is not given to you in the booklet, in the AdMath exam booklet. You will need to remember this identity and be able to apply it. So now we're going to move on to the other three identities, which you will be given in the exam, but we're going to work on proving them. So let's start with sine squared a plus cos squared a. Cos squared a is equal to 1. So they're using a as our x in this case. So I'm just going to change this angle theta to a. And actually, I'm going to change it to lowercase a just because it can get confusing. I'll change these two, because otherwise we confuse it with this a over here. Right. So now what we're going to do is prove that sine squared a plus cos squared a equals 1. So sine a, we know, is equal to opposite over hypotenuse. Cos a, on the other hand, is equal to adjacent over hypotenuse. So I'm going to literally substitute this in. So sine squared a is just, sine squared a, just to clarify, sine squared a is equal to sine a all squared. That's just the notation for it. It can be a bit confusing if you didn't already know that. So this means that we're basically substituting O over h squared plus a over h squared. And if we simplify this down, we get O squared over h squared plus a squared over h squared. And this becomes O squared plus a squared over h squared. And you may be wondering, how does that give us 1? Well, we need to get our good friend Pythagoras over here. So we know that with a right angle triangle, the two sides will squared added up will equal the hypotenuse. In this case, a right angle, which is over here, this side length squared plus this side length squared will give us the hypotenuse squared, which means that O squared plus a squared is indeed h squared. So h squared over h squared becomes our result. We can replace this with h, which gives us 1. And there, we've already proven that sine squared a plus cos squared a will give us 1. So this identity is valid. So let's move on to the next one. So secant squared a plus is equal to 1 plus tan squared a. So actually, I'm going to cover what secant is in more detail in a future video, but it's good if we look at it over here right now. So secant is equal to 1 over cos. And consequently, I'm going to say what cosecant and cotangent are since we're on that subject. Cosecant A is equal to 1 over sine A. And cotangent, or cotan, A is equal to 1 over tan A. So I know it may seem counterintuitive considering S for sine, but it's still cos at the bottom over here. So the way I think about it is, well, if it starts with S, just switch it up with cosine. So this one starts with C, but it has sine at the bottom. This one starts with S, and this one has cos at the bottom. So just flip it around the way that is natural to think, that cosecant A would equal 1 over cos A. I also made that mistake initially. Cotangent A is very easy. It ends with T for tan. So that one's simple. All right, now getting that over the way, let's move on to the identity. So secant squared A is equal to 1 plus tan squared A. All right, so we're going to write everything in terms of sine and cos. It's just a lot easier to collect in that way. So we know that secant is 1 over cos. So that means that secant squared is 1 over cos squared A, which is equal to 1 plus, and then tan squared A we know is sine squared A over cos squared A, since tan A is equal to sine over cos. All right, now what we want to do is write this right-hand side in one fraction. So we need to get the 1 out by multiplying it by cos squared A, multiplying and dividing it by cos squared A. So 1 over cos squared A is equal to, so 1 times cos squared A is cos squared A, and since we're multiplying it by cos squared A, we have to divide it by cos squared A, plus sine squared A over cos squared A. But we know, since cos and sine have the same denominator over here, over here, and because sine squared A plus cos squared A equals 1, so we're pulling from different identities, we know that that must be 1. So 1 over cos squared A is equal to, I'm just going to cross it out, 1 is equal to 1 over cos squared A, as required. So just a quick note about proofs. I did it in this way, although I would not recommend it. I'd recommend that you take one side. So in this case, I would take the right-hand side, since that has more simplification necessary, and you mold it into this answer over here. What you don't want to do is write down both sides like I have here, and then run the risk of bringing over things to the other side. So for example, you couldn't bring the 1 over cos squared A to the other side. It has to stay on each side. That's the point of a proof. You can't start manipulating the result. All right, so we have proven this one over here. So let's move on to the next proof, the last proof. This is the last identity you will be given in the exam, and the last one you really need, if I'm being honest. All right, so cosecant squared A is equal to 1 plus cotangent squared A. So again, replace everything with sine and cos where you can. So in this case, we're going to write this as 1 over, not cos, sine, I did that thing again, 1 over sine squared A is equal to, actually I'm going to write it down the way we'd prove it. So 1 plus cot squared A, that's the part that needs the most simplification, so I'm going to write that down. So 1 plus cot squared A is equal to 1 plus cosine squared A over sine squared A. So this is because cot is equal to 1 over tan, which is equal to 1 over sine over cos, which is equal to cos over sine. So that's just how I prove that cot squared A is equal to cosine squared A plus sine squared A, over sine squared A, sorry. So now we can multiply 1 by sine squared A and divide it by sine squared A to get it in the same, to get it as a fraction. So we have sine squared A over sine squared A, which is equal to 1, of course, plus cos squared A over sine squared A. And we know sine squared A plus cos squared A, again, is 1. So we can knock that off and get 1 over sine squared A, which we know is equal to cosecant squared A. So that's how we prove this last identity over here. So I think it's just very important to note that sine squared a plus cos squared a is very likely to come up in any scenario. So if you have a mixture of sine, cos, and tan, try and get it in terms of sine and cos, and hopefully there usually will be a solution where you can cross out sine squared a plus cos squared a and replace it with 1, and it'll give you the desired result. So that's a little intro into trig identities and the way you can solve them. Thank you so much for watching, and I'll see you in the next video.